Hello, everyone, and welcome you all to our first of three Q&A sessions for this year's Winter Systems at Scale. I am Shilpa Lawande, and I will be moderating our Q&A today. We thank you, first of all, to all the speakers for an engaging set of talks, educating us on AI, both scaling multi-tenancy as well as applying it to AI ops. So without much ado, let me get going with the questions. So the first question, let me start with you, Bikash. Can you tell us why you picked inference as the workload for accelerated multi-tenancy?
Sure, Shilpa. Thank you for this interesting question. Let me try to answer it. Inference workloads are characterized by a diverse set of models, which vary both in terms of compute and embedding complexity, as well as the infra resource requirements. These models are also diverse in the sense that they receive varying traffic across regional data centers. Furthermore, inference workload has strict perf requirements in terms of latency as well as throughput. Thus, this low complexity, low resource requirements, and low traffic models aren't always able to fully utilize accelerator resources. In fact, we have seen that sometimes not even a single accelerator device is being fully saturated due to such low footprint inference models. Therefore, multi-tenancy acts as a key infra lever, which provides the capability to further partition and share a single device across multiple co-located inference models. Unlike its counterpart training, which has very different workload characteristics and relatively high resource requirements, a lot of times such fine-grained multi-tenancy support may not provide the same level of benefits as we observe for inference workload.
Great, thank you for that. And a related question to Xiao, was GPU sharing for tasks used for training or inference as well in your work?
So for now, the sharing is most targeted for the training workloads because we do not use hardware partition to provide the best isolation. So there's just concern the performance isolation for inference is not good enough. So that's why we primarily target for training workloads.
Interesting. And just continuing the topic a little bit of workloads, you mentioned multi-GPU workloads are harder. Can you talk about a little bit more about?
Sure. So we target for the training, but mostly for the single GPU use case, which is not the traditional multi-GPU workloads. We tried for the multi-GPU workloads, and because it's super sensitive to any noise. If you had any noise caused either from a noise enable or some sharing, that may cause some cascading side effect in the synchronized training. So for that reason, we do not recommend for the multi-GPU workloads training.
Great, thank you. Let me switch to Nitin and Madhura a little bit. Can you talk about how you deal with data-related sort of anomalies like false positives, false negatives, things of that sort? How do you make your tools more accurate over time?
Yeah, thanks, Shilpa. I think that's a great question. So we actually, this is obviously a pretty big challenge for all investigation tools and observability tools. So everything, we have a multi-pronged approach for handling some of these issues. And just, I think the biggest takeaway is just having really solid instrumentation. So we can actually track and observe all of these analysis or investigation workflows that are happening on our AIOps platform. As we kind of touched upon in the talk, we do have a very tight loop with some of our highest priority on-call customers, and we kind of get continuous user feedback. So that's clearly a very strong signal. But beyond that, we have kind of scaled this out and built some automated data quality pipelines so they can kind of just look at critical incidents and root causes that humans who are investigating those incidents labeled and kind of look back at our automated investigations and see how they match and what the precision and accuracy sort of looks like there. And we also made it pretty easy for the engineers on our team to easily discover certain classes of critical incidents and then see how our tools were doing there. Beyond that, we provide some user-based annotations, so users can come in and say, yeah, we found this to be a conclusive finding or a non-conclusive finding, and kind of just track the overall quality of the AIOps system, and then we can just kind of dive deeper into that.
Got it. So it's basically a continuous feedback loop, both within the tools as well as with all of your user community and all the actual investigations that happen. Great. Okay, next, let me go back to Xiao, and there is an audience question about the cry for help mechanism you mentioned. Can you explain that in a little more detail? Is it basically restarting the task on a dedicated GPU, or is it? Can you explain?
Sure, yeah, I can share more in the details. So when we detect the performance anomaly, we will trigger cry for help. So during cry for help, we will leverage the hardware usage profile of the co-running task to decide if a task is a victim of the resource competition or it's the antagonist in the resource competition. So if it's an antagonist, so that means it's not suitable for future sharing. So we'll opt that out from the sharing. So that job will reschedule running on dedicated GPU. If it's a victim and can potentially continue participate in sharing, so we'll reschedule to another GPU, and it has the possibility to share the GPU with another job.
Got it. And how do you determine victim and?
Sure. So we leverage some hardware heuristic, and we try to estimate the HBM usage, the memory bandwidth usage, and also the compute usage. So it's a blend of hardware matrix that we try to differ. Basically, the more aggressive the task uses the hardware resources, we think it's more likely to be an antagonist.
Got it. Thank you. Hopefully that that answered the audience questions. But folks in the audience, if you're listening, feel free to continue to submit your questions, and we will take as many as we can. Very good. Going back to you, Leon, let me ask you a question. What are the big trade-offs you see between HMT and SMT forms of multi-tenancy? And can you talk a little bit more about the decisions on why you picked one over the other?
Thanks for that question. So the major trade-off between HMT and SMT is that HMT gives us stronger isolation guarantees, while SMT is better at handling workloads with more dynamic utilization. In other words, SMT has potential to give better efficiency, but on cloud infrastructures, isolation is often a crucial characteristics. That's the main reason why HMT is chosen as the GPU multi-tenancy solution for Meta.
And was this specific to Meta? This decision was more closely related to the way Meta's workloads operate, I imagine.
Yeah, it is mostly isolation. So because we run different workloads, and isolation is a crucial characteristics. We want to protect data, want to protect different workloads from each other. So we choose HMT.
Very good. Going to you, Nitin, let's switch tacks a little bit and say, there are tools, but there are humans who use the tools. I was wondering, is there any resistance you feel from people who actually do these investigations on trusting these tools or using these tools versus using their own instincts or methods to do the investigation?
That's a great question, Shilpa. We did encounter some resistance and a lot of skepticism too, right? There was not just a change to how people did their debugging, but this was a new tech and people had to invest in tuning things when they did not work well. Our key has been strong partnerships. As Madhura said, and I cannot emphasize enough, the role of early adopters in this journey. I talk about some of these in our talk, like Web Foundation team, Ads Manager, Instagram Reels. A tight feedback loop with our early adopters went a long way in evolving this for the broader adoption. We were able to identify teams across Meta which would benefit from these solutions. by leveraging what their mean time to recovery looked like, and then formed close partnerships with them as well. And once things got more mainstream, people gained more trust, and we were able to quickly scale up with more out-of-the-box solutions.
Great. And can you talk a little bit about going from these early adopters to broader adoption? What were some things you had to do to get that?
Yeah, for sure. So going from a few teams to broad adoption meant we had to make things a lot more easier to use and more out-of-the-box solutions. One thing that worked for us was our focus on making generalizable solutions from the get-go, even though we were working very closely with our partners, few teams, but we had a clear vision on how to invest and make things useful for the general teams at Meta, right? And in addition to the domain-specific tools, we integrate these into widely used observability and alerting tooling. So things were more out of the box for our users. And last but not the least, we leaned on things like in-tool advertising, highlighting where people could use these features to reduce their mean time to recovery, clearly showing the correlations to leveraging these to MTTR, and doing more education also in the bootcamp labs, where every new engineer joining the company is expected to spend the first few weeks learning the new company's tech. So this was useful to have for our new engineers joining the company.
Very good. A similar question to you, Xiao. How do you incentivize your users to adopt GPU sharing?
That's a very good question. So with our first approach, we tried to have a top-down mandate, but it failed miserably, as you can imagine. So instead, we provide incentive as a quota. So let's say the low-power job often get preempted by high-power job. But we tell them, hey, if you opt into GPU sharing, with the one physical unit of GPU, you can submit 2 jobs. So essentially, you double your quota or double your schedulable capacity. So that gives users an incentive. So their manager or director convince their own engineers, if you have a workload that can tolerate this kind of performance sensitivity, and you virtually can sub twice of the job. So that boosts their productivity. Like I said, we try to have the single GPU workloads, which are less sensitive to the performance, and they just have a small data sets to validate their model or configuration. So that eventually boosts their productivity. That got the customer buy-in. So that's the strategy we found out works best.
Great. Very good. Excellent. Let's see. Another question for you. Let's go to Hai. I don't think we've heard from you yet. Talk a bit about, as you productionized the system, what did you notice were the key advantages and disadvantages of multi-tenancy that you found?
Thank you. That's a good question. So there are 3 main key potential advantages of multi-tenancy that we observe. First is better scalability. So because multi-tenancy containers are smaller, so companies can scale up or down container fleet more efficiently to accommodate the real-time traffic. And second is the cost saving or capacity saving that we mentioned in the talk. Is because we can leverage the shared resources in multi-tenancy. Thirdly, this is like specific in our case, we observe lower latency for multi-tenancy containers. So there are 2 potential disadvantages of multi-tenancy that we don't actually observe during the productionization, but we observe during the implementation. So firstly, if we incorrectly implemented multi-tenancy can lead to security issues as multiple containers now share the same one device resource. Secondly, additional knowledge may be required to set up and use multi-tenancy containers, but we avoid this by because we well documented the setup of multi-tenant environment. And we also see that if the necessary resources are made available to customer, then it can help reduce the knowledge required during the setup process.
Very good. Thank you. Jen, I think a related question for you: how do the model characteristics impact multi-tenancy choices?
Thanks. That's a very good question. As we can see from the previous presentation that we have in terms of model complexity, which means number of flops per request for this model, and also model size. Our inference models varies a lot across a wide spectrum. And also plus that based on different model architecture, we have different model splits between this host usage and the device usage. So this resource requirement across host and device are also very different based on model structure there. And also the traffic are very diverse, which result in that we have a long tail of very low complexity, very low traffic, and very low utilized models. Because of such diverse resource requirements, one size fits all container size is very suboptimal in our serving world. Therefore, in conclusion, the model characteristic, both in terms of complexity, resource requirement, resource requirement including memory bandwidth, and network utilization. This will help us define a multi-dimensional, multi-tenant container shapes and satisfy the serving workload better. Yeah, that's it.
Thank you. Madhura, back to you. What is your approach to semantically normalized telemetry logs to detect, variety of problems?
Yeah, I think this is a great question. And I think as you touched upon in our presentation as well, sort of just identifying some of these correlations and really working on the data quality were like some of the most challenging problems for us. We did work very closely with like the data science team to really build out like our ML models for ranking these logs. And on top of that, our logging systems themselves do have a bunch of ways in which we can kind of aggregate these semantically. So we have hashes and things like that to represent broader error classes. And again, this was like in very close collaboration with the data science team. And similarly, we have a lot of support for indexing and metadata, which we can add on top of unstructured logs. Some of this is probably also covered under logarithm, which was another log at some point. So those are all of the different factors that really went in to build like stronger ranking models for figuring out those patterns.
Great. And just a follow up to you, like, can you talk a little bit about, you touched upon the idea of an assistive approach versus a fully automated one. Like, what might that look like?
Yeah, so this is a great point, and I think we didn't get too much time to cover that in our presentation, but we definitely talk about that a bit more in our blog, so do check that out. But essentially, this is an approach where we kind of go towards more of a decision tree type workflow, where we do automate as much as possible, but then there's a lot of opportunity for the human who's investigating the issue to come in and add more context as they kind of walk through the investigation. And we often found that for more complex problems, this was often like a pretty good approach for making sure that those could kind of be resolved more interactively, where we codify the harder parts, but we also allow users to kind of come in and override context during the critical investigation.
Great, thank you. So, I heard through all your answers, like there's a combination of tech and there's a combination of, people and convincing people to use the tech. So with that, I think we are at time for our Q&A session, for this Q&A session. If there are more questions in the audience that we could not get to, we will try and answer them offline. But look forward to seeing you after an upcoming break. Thank you all to all the speakers for answering all the questions and for the presentations.